We're going through the install of KiCad. Here first on Mac OS, I'm running Big Sur. 16 gigabytes of memory. And on the hard drive I've got probably 13, 14, 15 gigabytes left. So should fit. I'll choose the closest mirror, Mac OS. And I'll just put that disk image on my desktop. That's going to take a bit of time. So I'm going to pause this video and come back when it's done. Okay, KiCad has finished downloading. Let's try to find this on my crowded desktop. Here it is. Double click on that. Should bring up a window that looks like this. We do as suggested and put the program into applications. Let's make sure we're really doing a fresh install. Try that one more time. Yep, that time we got it. And we can see it here. All these programs that make up KiCad. For the main application. Can't seem to get this into application support. Let's look at the README. I have a password on my application support folder apparently. So let's fix that. Drag the two directory icons. Alright, I was asked to authenticate with an administrator username and password, so I just did that. Demos, I'm going to keep here and I'm going to put demos into my documents directory. Whole bunch of demo projects. The one we're going to start with is Pick Programmer, and that's what's inside there. So as soon as we're done with application support, we're going to try to open one of these files. So all these different extensions are for different parts of the design program. Very important. Pro is the project information of the whole project. KiCad PCB is the actual PCB layout, and SCH is a schematic. And so I'm gonna double click on the project. I get a little KiCad icon down here. Well, this is the usual security issue with new software on Macs. Let's go to System Preferences. Security. General. KiCad was blocked because it was not from an identified developer, and so we're going to say open anyway. Open. And that should pop up on a screen that looks like this. Put security away. open project, demos, pick programmer. There it is. And then now you can see location, users, elandall, it's my user account, documents, standard documents folder, demos, pick programmer.project. All right. This button should start the schema app. Brings up something like this. And it's worth remembering where this is, in case later you need to uninstall or change something. So it's going to put these libraries or a table that says where to find these libraries in this location. Elandall, my library directory, application support, KiCad template. So let's go with the default here. Having done that, I now get a screen like this that pops up, which looks good to me. I'm going to close out some of these other windows. So we can concentrate on this thing, which does look like a great big schematic. So that's pretty cool. Lots of tools on all the sides. For the moment, I'm going to just use my mouse to zoom in and out. So I have a scroll wheel mouse. And you note that I zoom into wherever I point it. So if I want to look at this transistor up here, I just put the crosshairs there and zoom in, and it automatically moves to the center of my screen. You know, or if I wanted to look, say at this diode, same thing, it just jumps to the middle of my screen when I zoom in and out. So that's kind of a nice way of moving around. A few things about the schematic. There's text labels near each of these symbols. So if I have a resistor, it's got both a number and it's got a value, so this must be a 10K resistor, which is labeled R4. And the green lines connect the pins. Here's this dot indicating that these lines all connect at this point. There's actually even labels on the wires in this schematic. So this green wire is labeled PC data in, for instance. So even the wire's got a label. Let's look at this over here. This is an example of a subsheet or a link to a schematic within a schematic. So I think if I double click on this, there it goes. It opens up the schematic that goes to. So it was a link to another sheet. So this is actually a much more complicated schematic than what we saw just originally. And so there's all sorts of additional components and wires with all their own labels on this sheet. Okay. Now, a cool thing is I can always just go and close this anytime I want, or click Leave Sheet, and I go back to the previous one. I'll just close this one also. Now I'm going to show you the other important subcomponent of KiCad. We're on the schematic layout editor. I'm going to go over here. That actually looks like a PCB. So you see it's a PCB layout editor. I double click on that one. And because I'm running it for the first time, it's going to give me another one of these warnings about copying footprint libraries. So the footprint is on the PCB, the shape of the component physically on the PCB. So it needs to know where those are located, and I'll take the default setting here also. And just keep in mind it goes in the library, application support, KiCad, template, etc. So I hit OK. Well, this is pretty neat, but I think I'm not going to take the chance at the moment with graphics acceleration, so I'll just say no thanks, and realizing I can speed things up later if I really care about that. I guess it's under preferences. No thank you. And it's brought up this screen. Some reason I've got nothing in here. So the reason that we're not seeing anything probably has to do with that graphics option that we selected at the beginning. And just to point out, there actually is a PCB file that's loaded, just not displayed. And we know that, first of all, because all these layers over here are checked. So these are all the different types of layers that might be displayed. So they're on, and then all the different items are also clicked on. And finally, most convincingly, we see that down here, the number of pads, vias, track segments, nodes, and that's all these components that are part of a PCB line. They're showing up. Notice how my cursor is also pointing out the same direction. So I really suspect that the problem is in the preferences somewhere. And if you recall, I did this fallback tool set. Let me do the modern tool set accelerated. Oh. And there we go. there is the actual PCB. So this is the layout that corresponds to the schematic, and I'm going to go back and look at the schematic. We can click on here again, and again to go to the PCB, we click on this, but don't click on this now because it actually forces a recompilation of the PCB, which we don't need to do. So if you change something on the schematic, you would hit this button to see a change in that PCB. We'll try that maybe in a minute. So the zoom works the same way, is centered on what you want, and there's several things to point out here. You can turn on and off individual layers, top layer, bottom layer. A rule of thumb is that the top layer red is the lines that are on the top of the PCB. So if you're picking up your PCB and looking from the top, you would see these lines underneath the purple photo mask if you're dealing with an Osh Park board. Whereas if you look at the bottom, it would be these green ones that show up. A few other definitions. The mask, stuff that's drawn on the front or on the back. The silk screen, we have nothing written on the back, but on the front we have quite a lot of information on the front silk screen. If I click on a particular component, so this is clearly an integrated circuit socket that would go in here, you'll see that it brings up a bunch of information about it. Component number, U again, is often used to refer to integrated circuits, so U2 happens to be a 74HC125. Tells you when it was changed. It goes on the front of the board, has 14 pads, you can tell that's true. Note the typical convention, which is that pin 1 gets a square, whereas the rest get an oval. Note also that on this footprint there is going to be some silk screening with an indent here. And very important, that tells you the name of the footprint package. And you'll see that those come up on the bill of materials. I'm going to create those two. Very cool in these newer versions of KiCad, I'll show you this in a moment, it also has a 3D shape associated with it down here. So this is a description of the actual footprint. This is a description of the 3D shape that's been associated with this particular part on this particular board. Use another one up here. Ask me sometimes, hey, what are you trying to actually point at? I'll click on R10, which is this resistor, I guess. I guess it's a 5.1K resistor on the front of the board. Here's its footprint name, and then here is its 3D shape. Also, more information that says 2 pads. Of course, it's resistor, so it just has 2 pads there on the left and right. And you go through all these and select things and find out what they are. Regardless, you should also be able to identify them back on the schematic. Let's look at R10 on the schematic, for instance. So there's R10. Bring up the schematic. R1, R3, R5. Where is R10? 19, 20, 18, 7, 9. 13, 12, 8. There it is, R10 right there. Zoom in on R10. What we just looked at on the PCB. I'll click on it here. It's got some information. Symbol R10. And I can see it's right on here. It's got a footprint associated with it, as well as its value and the reference number. All right, finally I'm going to open up the actual Thomas Henry 555 VCO, simplified with my modifications, the one we built in class. I've already grabbed that file and put it in my documents directory. So let me start up KiCad and file, open project, and then we have to find the directory, and it's VCO _C. That's been loaded over here. Let's get the schematic by clicking on the schema icon. And there it is. There's the capacitors, which are helping keep the power supply stable. You can see the power. It's set to plus minus 15 and ground in this diagram, but it's not concerned. There is you can see the inputs over here. Coarse, fine, volt per octave, and FM modulation. There's the pot for FM modulation, the pot for fine, and the pot for coarse. You can see the matched transistor pair with the feedback loop. For temperature stabilization. Here's the 555 timer. Again, whether you use a 555 or 7555 or the TLC 555, fine. You've got the ramp out and then the triangle wave out. Integrated circuits are in here. This one with the funny symbol is the LM13700, the voltage controlled op amp. Let's look at the PCB. And there it is. And you'll be able to verify the red traces are on top. The green traces are on bottom. That should look exactly like the board which you've been soldering. And then finally, we're going to look at the 3D view. Looks pretty slick. I have, however, not managed to implement 3D profiles for the potentiometers, the jacks, the IDC connector, or the big pots either. I think those are available, and it remains to be a project of someone to figure out how to get them into the 3D viewer. The capacitors I used as a generic capacitor 3D footprint, so not terribly important, although this was helpful in designing somewhat the acrylic faceplate.
All right, next we'll show you how to actually use the program.